Good morning, Vande Mataram, Jai Bharat, Jai Shri Swaminarayan. My name is Milan Dholariya. In this video, I will explain you theory part of chapter number 1. Our chapter number 1 is real numbers. Okay, so just be ready, open your mind, let's start it. First of all, Euclid's division lemma. Okay. For finding out HCF, Euclid give one method. Okay, it is called Euclid's division algorithm. Okay, so first of all we will start with Euclid's division lemma. For finding out HCF, Euclid give one method. Okay, that's why we are learning this. So first of all, Euclid's division lemma. Given positive integers a and b, there exist unique integers q and r satisfying a is equal to bq plus r, where r is greater than or equal to 0 and less than b. Okay, again, given positive integers a and b, there exist unique integers q and r satisfying a is equal to bq plus r, where r is equal to greater than or equal to 0 and less than b. Okay, now Euclid gives one method in which division rule is applied. Okay, first of all, for finding out HCF, at least we want the two numbers, right? At least we require two numbers, and for that two numbers a and b, that two numbers are a and b. Okay, then what we need to do? We need to apply a division rule. Okay, we already learned this rules in our chapter number 2, polynomial, right? That means if we divide 5 divided by 2, okay, and 2 to the 4 and 1 is remainder, right? Here this number is a, this is b. Okay, here our answer that is q and remainder it is r. Okay, in chapter number 2, this is our p of x, this is our g of x, q of x and r of x, and we learn this is same rule. That means this number a is equal to multiplication of that two number, 2 to the 4 plus remainder 1, 5. So a is equal to 2 to the 4 plus 1, 5. That means b multiplied q plus r. Okay, so here a is equal to bq plus r. Okay, same thing we need to apply here. Whatever two numbers are given, first of all we need to divide it and we need to apply this rule. Okay, bq plus r. Here our a is greater than b. Okay, a is greater than b. Otherwise the division is not possible. It is possible but in decimal numbers, right? But if we want answer in integers and we want remainder, so alternately we cannot divide it. If our b is greater than a, okay, so our a is big number and b is small over here. Okay. One more thing. Here our r, that means this remainder, it cannot be equal, otherwise greater than b. It is always less than b. It can be 0. It can be 0. It cannot be negative number. But it is always less than b. Okay, remember r cannot be a negative number. Okay, either our remainder r is equal to 0, otherwise it is less than b. If you get r is equal to b, otherwise more than b, then definitely there is some mistake in your division. Okay, I give one example for that. 17 divided by 3. Okay, here 3 5s are 15. Okay, remainder 2. Let's take 16. 3 5s are 15. Here remainder 1. Let's take 15 even. 3 5s are 15. Remainder 0. Now just consider 18. So 3 6 are 18. 0. That means any number is in any number if you divide. Okay, so here for example I take here 15, 16, 17 and I divide with 3. If I divide with 3, then for 15 my remainder is 0. For 16 remainder is 1. For 17 remainder is 2. But after that for 18 my remainder is not 3. It is not equal with the b. Okay, it is always less than b. Again start with 0, 0, 1, 2, 0, 1, 2, 0, 1, 2. But you will never get remainder as 3. Otherwise more than 3. Okay, you get this type of series in remainder if you take the consecutive numbers. Okay, you will get the remainder 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2 and so on. You will never get the remainder 3. And if you get the remainder 3, let's suppose here 18 divided by 3. So 3 5s are 15. Then it is possible we get the remainder 3. But here, what is our mistake? We can factorize with the 6. We can put here 3 6 items, but instead of we are putting 3 5s or 15, that means here is some mistake. Right? We take a less number, that's why we get the remainder is more than b. Otherwise, never we get the remainder is greater than b. Otherwise, equals to b. Okay? Always it is a less than b. Yes, it can be 0. Okay, so here, which rule we need to apply? That means for the chapter number 2 polynomial, our division algorithm, right? A is equals to big Q plus R. Same thing we need to apply here. So number A is equals to big Q plus R. That means here exactly what we need to do. We just need to divide our number A with B. Okay? If we want to form this type of form, if we want, then what we need to do? Just divide number A with B. Okay? This is one algorithm, division algorithm that I explain you directly in the exercise. Okay? How we can find the SCF by Euclid division method. I will explain directly in the exercise. Okay, next, fundamental theorem of arithmetic. Fundamental theorem of arithmetic. Every composite number can be expressed, otherwise factorized, as a product of primes, and his factorization is unique apart from the order in which the prime factor occurs. Okay? What this theorem says was, every composite number can be expressed as a product of primes and its factorization is unique apart from the order in which the prime factor occurs. Okay, composite number means what? A number which is not a prime number, it's called composite number. Right? Composite number means what? A number which is not the prime number, it's called composite number. Okay? And for prime number is only divided with itself, otherwise 1. Okay? It cannot be divided with any other number. Okay? It can be divided, but we get the answer in decimal. If we want answer as an integer number, then prime number is always divisible with the itself, otherwise 1. Okay? And composite number means what? A number which is not prime number is called composite number, and every composite number can be expressed as product of primes. Okay, we already learned the prime factorization method in standard 8. Right? We also use that method for finding out the LCM even. Right? So every composite number can be expressed as a product of primes, and that factorization is unique. That means you can there is only one way to find out the prime factors of the composite number. Okay? There is only one solution of the prime factorization of the composite number. That's why it is written here, its factorization is unique. You cannot find its a factor other than your first answer. Apart from the order in which the prime factor occurs. Maybe your order of your prime factors can be changed, but you will get the same answer. Let's take one example. if we talk about one simple number 6, 6 is a composite number. We can express this 6 as a 2 3s are. Right? 2 multiply 3, 6. So these two are the factors of 6, 2 and 3. Okay, this is a unique way. Now, you cannot find any other factor rather than this 2 and 3. Okay, you cannot find any other prime factor rather than this 2 and 3. This is only unique solution. Okay, second thing, maybe you can say that factor of 6, it is 2 and 3, otherwise 3 and 2. Okay, order can be changed, but you cannot get any other number. Okay, if you talk about 27, sorry 21, let's take 21. It's a 3 7s are 21. Otherwise 7 3s are 21. Right? Rather than there is no any unique way, no any solution for factor of 21. It's only 7 and 3. Okay? Other factor we have, that is 21 itself and 1. Okay, but if we talk about the prime numbers, then 3 and 7 are the only factors of 21. Because 21 itself it is not a prime number. That's why here I am not write that 21 Manza. Okay, and 1 is not a prime number. Prime number start with the 2. So if we talk about the prime numbers, then for 21 we have only two factors, that is 3 and 7. Okay, that's why it is written here. Every composite number, every, can be expressed as a product of primes and his factorization is unique. Okay, you cannot find any other prime factors apart from the order of the prime factor. Okay, you can change the order, but you will not get any other answer. Okay, and by this rule, we just do the factorization method and we can find the LCM and HCF by the factorization method. Okay, in this chapter, we will find the HCF and LCM by Euclid division algorithm, and we also find HCF and LCM by fundamental theorem of arithmetic. That means by factorization. Okay. Then next is, if P is a prime and P divides A square, then P divides A, where A is a positive integer. Okay. If P is a prime number and P divides A square, then P divides A, where A is a positive integer. Okay. That means if A square is divisible by P, okay, if A square is divisible with any number, then obviously A is also divisible with that number. Okay. If A square is divisible with P, then A, it is also divisible with P. Okay, let's take one example. If we talk about 36, okay, 36 is divisible by 3, right? Divided by 3, we get the answer 12. This is, for example, our A square. Okay, here A square is divisible by prime number P. If A square, that means 36 is divisible by 3, then it's a square root. That means A is also divisible with 3. Okay, what this theorem says to us, if A square is divisible with any number, then A is also divisible with the same number. Okay, for example, if we take A is equal to 6, then A square it is 36. Okay, if 36 is divisible with 3, then obviously square root 6 is also divisible with 3. Okay, if we think about the factors, then always a square root is always a factor of its perfect square number. Okay, square root, it is always a factor of perfect square number. I am not talking about prime numbers, but I am only talking about the factors. Why? Okay, that means A multiply A, it becomes A square. So obviously, if we factorize A square, then we get the factor A. Factor is A, we can get, right? Then if our A square, that means 2 times A, is divisible with any number, obviously our 1A is divisible with that number. Okay? That means what I want to say, if 36 divided by 3 is possible, obviously 36, that means 6, right? 6 multiplied 6. If 36 is divisible by 3, then obviously its factor is divisible by 3. Okay? What is the factor of 36? 3 to 2, right? If we think about the factors, then if 36 is divisible with 3, it means 6 6 are 36. So obviously this number, square root 6, is always divisible with that number. Okay? We can take other examples too. If we talk about 81, right? 81 is divisible with 3, 27. Then square root 9 is also divisible with 3. Okay, you can pick any number. If your perfect square number is divisible with any number, then obviously square root, that means your number is always divisible with the same number. That means if a square is divisible with some number, any prime number, then obviously your a is also divisible with the same number. Okay? If a square is divisible with b, then a is also divisible with b. Okay? So these things we applied in the sums of irrational number. Okay? If you want to prove irrational number, at that time we use these things. So just keep in your mind. Okay? Then here, next is x is equals to p by q. X is equals to p by q. It is a rational number where q is not equals to 0. Okay. Here I am writing for the rational number, right? What is rational number? If a number can be represented by p by q, okay? If a number can be represented in the form of p by q, then it is called a rational number, right? If a number can be expressed as a p by q, it is called a rational number where q cannot be 0. That means our denominator cannot be a 0. Because if denominator is 0, then it goes to the infinite number, right? So here, if a number can be represented by p by q, then it is called a rational number. Okay? These things we already learned in our standard 8 and 9. Definition of rational number. Okay? Rational number is always expressed as p by q. Okay. If this is a rational number, then what is irrational number? Okay, what is the definition of irrational number? If any number is not rational number, then it is called irrational number. Right? If a number is not rational number, then it is called irrational number. There is no any specific definition for irrational number, right? If number is not rational number, it is called irrational number. Okay. One more thing for the irrational number. If in under root we have prime numbers, it is always irrational number. Okay? If in under root we have prime numbers, then it is always irrational number. For example, we can write here under root 2, under root 3, under root 5, under root 7. Okay, because here 2, 3, 5, 7 are the prime numbers. Okay, so square root of any prime number, it is always an irrational number. Okay, square root of any prime number, it is always irrational number. So here, under root 2 is irrational number, under root 3 is irrational number, under root 5 is irrational number, and under root 7 and etc. All the prime numbers, that means square root of all the prime numbers is always irrational number. Okay. The next, rational number plus, otherwise minus, otherwise multiply, otherwise divide. Irrational number, it is always irrational number. That means if you take one rational number and one irrational number, then for this all fourth arithmetic operation, addition, subtraction, multiply, division, you will get the answer as a irrational number. Okay? If you add rational number with irrational number, otherwise you subtract rational number with irrational number, otherwise you multiply your rational number with irrational number, otherwise you divide rational number with irrational number, you always get answer as irrational number. Okay, that means if your one number is irrational number, then definitely you will get the answer as irrational number. Okay, next, one number A multiply second number B is equals to SCF of A and B and multiply LCM of A and B. Okay, this is very important formula for you. Okay, if we have two numbers, then multiplication of the two numbers, it is equal with the SCF and it is equal with the product of its SCF and LCM. Okay, if you have two numbers, then multiplication of two numbers is equals to product of its SCF and LCM. Okay, let's take two simple number 12 and 18. Okay, if we talk about the 12, then it is 2, 2, 3, and here 6 to the, so 6, 2, 3, 4 3 is 12, no, here 3, 3 and 2, okay, 12 that means 2 to the 4 3 is 12, and here 18 that means 2 3 is 6 3 is 18. Okay, what is the SCF? I will explain you these things in briefly while we solve the exercise. Right now directly I will find the SCF. SCF, that means what? Whatever same factor we have in this two number, it's called as SCF. Okay, that means same factor in both this number. If you see the factor of 12 and 18, then 2 2 here